Maybe I'm not being clear. If we spent $50 trillion to become carbon neutral by 2050 in the United States of America, how much is that going to reduce world temperatures?
This is a global problem, so we need to reduce our emissions and we need to do everything we can.
How much, if we do our part, is it going to reduce world temperatures?
We're 13% of global emissions.
You don't know, do you?
So we're 13% of global emissions.
If you know, why won't you tell me?
If we went to zero, that would be 13%.
You don't know, do you? You just want us to spend $50 trillion, and you don't have the slightest idea whether it's going to reduce world temperatures. You're the Deputy Secretary of the Department of Energy.
Ooh, you already know what it is. It's your boy Laid Back with another reaction, another review, another episode. Hey, TikTok, you up to bat. Bow. It's your boy Laid Back. Welcome back to my channel. Hey, two things we got to do. You got to hit that subscribe button. I'm drinking this water. You already know what it is, man. You are the prize in 2025. You are the prize in 2025. Make sure you hit the like button. Make sure you hit the notification bell. Stay up to date with all the videos. We back with another reaction. We talking about weather, climate, all type of stuff going on in the atmosphere. Just a lot of stuff going on here, man. You make it to the end of this one, you a real one for real. Make sure you put that in the comments. Make sure you hit the like button. Don't forget to hit the like button. Also, I got a TikTok playlist. If you into this stuff, man, you can binge watch, but I would just say proceed with caution because there's a lot of stuff going on in those videos. Also, share this with the last person you text in your phone, man. I'm just saying, what's up, man? But let's go ahead and get into it. Fire Squad, what's popping? Let's get it.
Question is, Brendan, what are your thoughts on climate change? This is sort of a broad question, but I think I can answer it. Look, what we have going on lately is they're sort of trying to blame people and certain industries for climate change when there's two things going on. One, our climate just changes, naturally. We have the ice age. We have, our climate goes through massive cycles. Okay, so there's that. Now, pollution is a huge issue. Pollution is real, and I do think we are negatively affecting our Earth through all the pollution that we do. And, this is often done by these giant corporations. Let's look at Coca-Cola, for example. I did a deep dive into Big Soda and how many single-use plastic bottles that they produce. It's over a billion per year. Okay, so we have a billion single-use plastic bottles per year being produced, probably more. The number's probably much more, but that's like confirmed. And those end up in our oceans and they end up polluting. I think that's really, really horrible. I think that's what we should focus on in terms of this climate change thing. When you look at these really dumb headlines that cows are ruining the environment, when you look deeper into that, it's not true at all. Okay, I think a lot of what's happening is they're going to try to place this blame on you, and they're going to be telling you, hey, you need to take shorter showers. You need to not flush your toilet. That's literally a thing in California people have said. Meanwhile, there's a golf course right near us that uses more water than we will use in 5 or 6 lifetimes. Okay? So think about what's happening with these green taxes. Climate change is real. Pollution is real. But how we're going to handle it as human beings, I think a lot of that responsibility should be placed on the people doing the most polluting.
Do your own research. Do your own research.
Do we actually realise the impact of these wildly realistic AI videos? Because we're being warned that generative AI is accelerating the climate crisis. We've already heard that AI chatbots could use a bottle of water to write the average 100-word response, and that saying please and thank you to ChatGPT costs OpenAI millions of dollars in electricity. Receiving the data, storing it, training the AI models, and then responding to us uses massive amounts of energy.
AI does not live in the virtual reality. It doesn't live on the cloud. It lives in a physical data center that requires physical resources to run it.
Just keeping the servers cool enough to function requires...
I never, ever even thought about that. I never even thought about that. Y'all let me know in the comments. Did y'all even think about how they get the energy to respond? Like, that's wild.
Huge water systems or electrics like aircon. And the thing is, data centers can't be built anywhere in the world, like Iceland where it's colder. They have to be built in places that aren't prone to natural disasters, attract investment, are around reliable energy sources with people to hire and a good water supply, which then clusters these centers and risks deforestation, land use change, a strain on resources and materials.
In a place called Querétaro in central Mexico, where pressure on local water supplies have led to issues like drought.
So when you look at these incredibly detailed video generation models like Google VO3, surely the environmental impacts are even worse.
The more complex the application, the more computing power it would be required as a result, and therefore the more energy intensive it would be.
The fact is, AI is developing at such a rapid pace that we're struggling to comprehend what's real and what's artificial. But do companies and we as users need to stop and think more about its impacts?
Absolutely. I ain't never even thought about that.
Scientists have just uncovered something extraordinary, and no, this is not a metaphor. Certain fig trees in Kenya are literally turning carbon dioxide into stone.
What?
Yep, Medusa level. And the implications for climate change and agriculture could be huge. Here's how it works. Like all trees, fig trees absorb CO2 through photosynthesis.
Right.
But some fig species, like Ficus wakefieldi, take it a step further. They use that carbon to produce tiny crystals of calcium oxalate inside their trunks. Then, when those crystals break down, microbes in the tree and soil convert them into calcium carbonate, the same stuff you find in limestones and chalk. What's wild is that this calcium carbonate isn't just forming in the soil, it's showing up inside the actual trees, under the bark and deep into the woods. Basically, these trees are locking away carbon in rock-like forms that can last for hundreds, maybe even thousands of years.
Wow.
This process is called the oxalate carbonate pathway. It's been known for a few tree species, but until now, nobody realized just how powerful it could be, especially in trees that could also give us food. Because here's the kicker. These fig trees aren't just carbon sinks, they also grow edible fruit. That means that they can fight climate change and feed people at the same time.
Whoa.
Game changer. But that is not all. See, the process also increases soil pH levels, improving nutrient availability and making the surrounding land healthier.
Wow.
So these trees just aren't passive carbon storage units, they actively enhance the ecosystems they're planted in. Researchers are now trying to quantify exactly how much CO2 these trees can trap, how water efficient they are, and whether we can scale this up through agroforestry. Imagine trees producing fruit, enriching the soil, and quietly locking away carbon in mineral form for centuries.
Wow.
Dr. Mike Rowley from the University of Zurich said it best. We've known about this pathway for a while, but we're only now realizing its full potential, especially in food-producing species. So next time you see a fig tree, and yes, I know the chances of you seeing one are quite low, just know that it might be fighting climate change in ways we never expected, quietly, elegantly, and quite literally turning air into stone.
Bruh, that is crazy. And I was in Kenya earlier this year. That is fascinating. That is fascinating.
If we melt the Siberian tundra, there's like a massive amount of trapped gas and dead plant matter that's frozen solid. Now, if that warms up and that decays, that could put a massive amount of CO2 into the atmosphere, potentially. And like if you saturate the carbon sinks and you have a sudden release of CO2 from something that was previously frozen solid, that's where you could have a nonlinearity and things could go haywire pretty fast.
What could happen then?
Earth would heat up, water level would rise, you'd have a higher probability of extreme weather events. Shall we hit the fan? You can't just change the chemical makeup of the atmosphere and oceans and expect nothing's gonna happen. This is just a chemical reaction, man.
As far as we know, there have been 5 major extinction events on our planet. Events caused by changes so severe that many species simply can't adapt and, as such, die out. Right now, we are in the midst of the Earth's 6th mass extinction. One every bit as profound and far-reaching as that which wiped out the dinosaurs. It's almost impossible to grasp as we go about our lives that the rest of life on Earth is experiencing destruction on the scale of that wrought by a colossal asteroid collision. But consider these facts. 96% of the mass of mammals on our planet today are us.
Wow.
And the livestock that we've domesticated.
Wow.
Only 4% is everything else.
Wow.
From elephants to badgers, tigers to bats. 70% of all birds are now domesticated poultry, mostly chickens. Nature once determined how we survive. Now we determine how nature survives.
Wow. Bruh, that was heavy.
The numbers are in, and scientists can now say officially that 2024 was Earth's warmest year on record. Global temperature numbers last year also stood out for another unwelcome reason, which is that they were the first to rise above 1.5 degrees Celsius, or 2.7 Fahrenheit, warmer than the average before the Industrial Revolution. This record global temperature was reflected all around the world last year, from India, where it led to prolonged heat waves, to hurricanes in the Gulf Coast, which were supercharged by warm ocean waters, to Los Angeles, where hot and dry conditions set the stage for the destructive fires this week. This chart shows how much global emissions of carbon dioxide into the atmosphere have increased over the past century.
Dang.
That peak at the end of the chart is 2024. These emissions need to go to zero if Earth's temperatures are to be stabilized.
Whoa.
And so scientists often talk about bending the emissions curve. If societies had started bending this curve in 2005, when the Kyoto Protocol, the predecessor to the Paris Agreement, came into place, they could have done so gradually. If countries had started bending the curve in 2015, when the Paris Agreement was adopted, they would have had to do it by cutting emissions a little more steeply. So today, it looks basically impossible. The line is so steep that it sort of represents shutting off power plants worldwide, which would obviously have political, social, and human costs.
There is no kind way to put it. The 1.5 degree goal is on life support. It is in intensive care.
So where does that leave us? 1.5 is not a number in nature, it's a number in diplomacy. It's the aspiration that nations set for themselves a decade ago in the 2015 Paris Agreement. Nearly 200 nations agreed on 2 targets for global warming. They said they would try to pursue efforts to limit it to 1.5 degrees, but failing that, they would also try to keep it well below 2 degrees Celsius. A 1.5 degree world is one in which about 14% of the world's population is expected to experience severe heat waves at least once every 5 years. A 2 degree world is one in which 37% of the population experiences such heat waves. But failing to meet that goal doesn't mean we've failed to halt climate change entirely. Even at the time of the Paris Agreement, a lot of people thought keeping global warming below 1.5 was already very unrealistic. In retrospect, some people do think it had an effect of forcing companies, industries, other kinds of organizations to think more ambitiously about how to decarbonize their own work, how to move society away from reliance on fossil fuels. But when it comes to avoiding the worst impacts of climate change, scientists like to emphasize that every tenth of a degree counts. 1.6 degrees of warming is worse than 1.5, but 1.7 degrees is worse than 1.6. So even if the goal of staying below 1.5 degrees of warming doesn't seem feasible anymore, scientists say that's not a reason to stop trying.
I agree with that. I completely agree with that.
Coal burning is crazy. You ever see those documentaries on people that live in there's a certain area of Indiana? It's nasty. Like you go by people's cars, you could just like swipe your hand on a windshield and you have this coal dust. Like it's in the air. People are breathing it. All kinds of people are having all kinds of respiratory diseases as I suck on this cigar. A coal-fired power plant that does that. You should start it. You go, let's see what happens when we burn coal and make electricity. Okay, let's try it. Oh, it's super efficient. Seems to work really well, but it really fucks up the sky. Let's not do that. But back then, they're like, let's fuck up the sky just in this spot. Nope.
Wow.
And predecessors of ours would have never guessed that we'd be hanging on this long.
Wait, how much longer do you think we got?
Not much time.
Wait, really?
Yeah, I think, unfortunately, the way things have unraveled over the last couple of years, I have zero faith that we're going to keep this thing glued together for another 10 years or 20 years.
Really?
If you haven't already heard, the UK is spending £800 million into trying to dim the sun. Yeah, you heard that right, to dim the sun in the UK. It's projected to start within the next few weeks, so we'll see the results very soon. They're going to be injecting aerosols into the atmosphere and brightening the clouds to reflect sunlight. I can't believe this is happening. They'll be using sulfur dioxide, calcium carbonate, and aluminium oxide particles.
Hold on, man. Y'all know I love the beautiful women out in the UK, but...
Oh, hell no!
What?
The problematic thing, sulfur dioxide is toxic to breathe in and it can damage ecosystems, including plants and water sources. And aluminium particles can bioaccumulate in our soil and water, so again affecting ecosystems, our wildlife, our plants, and potentially even us ingesting that from our water sources to us growing crops on the land. My biggest question is, why are they doing this in the UK when we don't get enough sunlight as it is? We are not really suffering the effects of global warming because it's never really that hot unless we have kind of a 2-week heat wave. But there's places in the world that are being significantly affected and constantly have sunlight. So why aren't they testing them in those places? And also it's this non-consensual thing of we're already deficient in vitamin D. It is a known thing that the UK population is deficient in vitamin D. So why are we dimming the sun even more? That's potentially catastrophic to the population's health. And another thing that I wonder, if they're investing £800 million into really just masking the symptoms of climate change and environmental effects, why wouldn't they use that money to actually make stricter laws about plastic consumption or chemicals that we're using that are affecting our ecosystems? Why aren't they using that money in a way that can actually combat and prevent climate change? Why are they already trying to mitigate it in the future? I don't think we need any more exposure to toxic chemicals, and I'm sick to my stomach of being guinea pigs and not consenting to these things that they are testing on us. And it's constant. I'm hearing stories and changes that most of the time do not make it to mass media, are kind of swept under the rug, and people on TikTok or smaller kind of journalists are talking about these changes that the government are silently making. And it's just extremely frustrating to me. We're seeing so many people get sick now more than ever. We're being overworked, we're being exposed with chemicals that are unprecedented, untested, and have no longevity in the data. And we've, seen in isolated studies already that they are making us sick. And yet, the governments aren't protecting us. And it's getting to the point now where I think it's so important to be talking about this kind of stuff amongst your friends and to be sharing videos or making yourself aware of these things, because the mainstream media or the government itself are not going to inform you that they're putting some unprecedented, untested thing into our ecosystem that could definitely affect us.
Bruh, the UK, that's wild, bruh.
Watch this report from CBS on blocking out the sun. They're doing like a deep dive promotion of this entire plan. Just look how they're sort of jolly about talking about it. Watch.
What exactly is solar geoengineering?
A set of proposed technologies to rapidly cool the Earth by reflecting sunlight back into space.
The idea is based on the cooling effect of volcanic eruptions. When Mount Pinatubo in the Philippines erupted in 1991, it spewed 20 million tons of sulfur dioxide into the sky. That reflected so much sunlight, global temperatures dropped by an entire degree the following year.
So we could mimic those volcanic eruptions by sending specially equipped airplanes into the stratosphere to do exactly the same thing.
Bro, these people be on some bullshit.
Scientists say 2 degrees Celsius of warming is a critical tipping point. So what actually happens if we reach it? It's more than just hotter summers. It actually changes everything. A hotter planet means more energy in the atmosphere, which means supercharged storms, longer droughts, and record-breaking heat waves. In many places, extreme weather can go from once in a century to once in a decade, or even worse. Up to 18% of Earth's species could go extinct. That can mean coral reefs nearly gone, Arctic ice rapidly disappearing, and these aren't just pretty places, they're key parts of ecosystems. When they collapse, food chains break down and entire habitats are lost. Climate change also doesn't hit everyone equally. Low-income and frontline communities face the brunt. Flooded homes, failing crops, and heat with no AC. There could be hundreds of millions of climate refugees by 2050. And as resources shrink, conflict and instability rise. But we still have a shot to avoid the worst outcomes. Every fraction of a degree matters, and every action matters. At Acclimate, we help businesses and individuals measure, reduce, and offset their carbon footprint so that we can fight climate change. If you're interested in figuring out your own impact on the planet, you can go to the link in our bio and take our free carbon footprint calculator quiz. Let me know what you think down below.
Have you ever heard of the Doomsday Glacier? Bad news, its melting is now unavoidable. This is the Doomsday Glacier, aka the ice shelves of Western Antarctica. Just to give you a sense of scale, it's this entire sheet of ice right here beneath the South Pole. Almost 2 million cubic miles of ice.
Wow.
If all of this ice melts, global sea levels will rise 17 feet. That amount of sea level rise, half of Sacramento is underwater. New Orleans is basically gone or converted into an archipelago of tiny islands. Florida Everglades are basically turned into an inland sea. The entire region of China's east coast where millions of people live is deleted. Tokyo Bay gets significantly larger, much to the dismay of the people living in Tokyo. Huge sections around Mumbai and New Mumbai are just gone. Another place where millions of people live that are converted to networks of tiny islands. And I just want to reiterate that the loss of the West Antarctic ice shelf is now considered unavoidable. So this level of sea level rise is almost guaranteed. That sea level rise is just from the West Antarctic ice shelf. It doesn't count all of the other glaciers all over the world that are also melting. The maps that I showed you will likely be worse. And this is not happening in 2 centuries or next century. This is happening this century. And it's more than a little scary that the worst affected places in the United States are typically more democratic places that actually care about these issues. So I'm sure that will play out well.
Man, this sounds nuts, man.
So what's wrong with global warming if it'll delay the next ice age?
Because it's too much of a good thing.
Right.
If there was no carbon dioxide greenhouse effect, the Earth would be frozen pole to pole like it was during snowball Earth.
That would be,
right. So the natural greenhouse is a good thing, but we have increased the amount of carbon dioxide in the atmosphere from its natural amount by about 50%.
Damn.
And because carbon dioxide is the principal climate regulating gas in the atmosphere, that's a big deal.
So, and when you say this 50% number that you, and many will say, how do you know that it's us that's doing that? What makes you say that we have made this 50% increase in the greenhouse gas?
So we built all of civilization as we know it in a relatively stable interglacial period.
That's correct.
Which is a little delusional because we think that's just Earth, but it's not. It's just a temporary state.
Yes, because it would go for another 8,000 years or so before we went into the next ice age.
Damn.
This is the atmosphere. Over the years, humans have carelessly pumped billions of tons of emissions into the sky, and now the consequences are coming back to bite us. It's a global problem, but certain countries have played a much larger role in pushing us to the brink. All of us have contributed to the climate crisis, but these are the 10 countries who have done the most damage over the years. Rounding out the bottom are Japan with 2.7% of the world's emissions and Canada with 2.6%. Those numbers might not seem like a lot, but remember, we're talking about megatons of carbon dioxide spewed into the atmosphere since 1850. Next is the UK with 3%, followed by India at 3.4%. Germany takes 6th place with 3.5%, and Indonesia has contributed 4.1%, while Brazil is responsible for 4.5%.
America gonna be crazy, what?
Not very full, is it? That's because we're getting to the true culprits now. Russia is the 3rd highest historical contributor with 6.9%. China is in 2nd place with a whopping 11.4% of the global total, meaning it's responsible for about 0.1 degrees Celsius of warming to date. In fact, China has surpassed America as the world's largest annual emitter of CO2 in recent years. But historically, the country doesn't even come close to the US. Since the Industrial Revolution, the United States has emitted 509 gigatons of CO2 into the atmosphere, a staggering 20.3% of the total, nearly doubling China and tripling Russia. By far, it's the richer countries that have done most of the damage to our atmosphere and environment, leaving lower-income countries in the global south to suffer for our actions. When it comes to the climate crisis, our cup runneth over, and while pointing fingers doesn't solve problems, it does show upon whom the onus to fix things lies, and that's largely with America. The transformative climate provisions of the Inflation Reduction Act have recently become law, allotting roughly $369 billion of investment in clean energy and environmental justice. State and city governments have a crucial role in combating the climate crisis, enacting policies and prioritizing budget that will reduce carbon output and strengthen protections for the environment. There are 36 gubernatorial races alone this year, in addition to the countless other state and local offices up for grabs. America has helped make the mess that is the climate crisis, but in this election, America also has the opportunity to clean it up.
Man, America be on that.
Joe Rogan explaining global warming to Candace Owens. Have you ever seen this one?
I don't know if I've seen that
It's
one.
tremendous. Like, he's going step by step. I believe that Democrats massively exaggerate how much the effect of global warming, but I do think man-made global warming is a thing that will happen.
Yeah.
Both things can be true.
Right. Global warming can be a real thing,
Yes.
but the extent of which man has affected it can also be debated.
Well,
and how much money you throw at it can also be debated.
Correct.
But is the climate changing? I have climate experts that come onto PBD podcast to Valuetainment, and totally disagreeing, but they agree that climate is changing.
Yes, but the thing is, if I say it's going to happen in 800 years, we're not going to get money for it in Congress today. Right. That's the problem.
That's a marketing agenda.
Right. So we can have that disagreement, but like he's explaining this to her, and it was like, well, because he's a moderate, then he's an idiot. And the messages that I saw when Neil deGrasse Tyson went on PBD's podcast, I was like, dude, what are you doing? Like, he's just making statements. He's not a slave to a woke narrative. He's a scientist. And I just feel like we've gotten to the point now where, like, if you have anything to say, on either side, by the way, on anything, if I were to say that a 9-year-old should not be able to get gender reassignment surgery, now I'm transphobic. How the is that possible? How did we get to this point?
Yeah.
The ocean is dead. We have killed it.
Dang.
You might have a question. How did we, humans, kill the ocean? After all, the ocean has been such a force for billions of years on our planet. The answer is quite simple. Do you know what sets our humanity apart from all other species that have ever existed on Earth over billions of years? We started doing something no one had ever thought of before. Producing synthetic hydrocarbons, more commonly known to you as plastic. Before us, there was no plastic in the ocean. And starting from the 1950s, all the plastic produced on the planet, sooner or later, ended up in the ocean.
Dang.
And now, by various estimates, there are between 75 to 200 million tons of plastic in the ocean. If you were to add up the surface area of all the plastic trash islands in the ocean, it would be equivalent to the size of the United States and Australia combined. Moreover, the volume of plastic that is visible on the ocean's surface is only a tiny fraction, no more than 1% of all the plastic.
1%.
As the majority of it is dispersed deep within. By the way, it is for this very reason, for the first time in history, that coral reefs have started to die. These massive living organisms in the ocean that existed for billions of years without trouble. All of this is because the ocean now contains plastic. Why is plastic so dangerous for the ocean? Since plastic does not biodegrade and decompose in the environment, a significant portion of it simply breaks down into smaller particles known as micro and nanoplastics. These particles permeate the entire depth of the ocean. Practically every drop of the ocean contains nanoplastic particles. Due to its specific composition, microplastics have a unique property. They disrupt the ocean's heat conductivity. Due to the presence of microplastics, today, the ocean cannot dissipate excess heat from the magma, which is overheating due to the additional energy being directed towards the planet's core from cosmic influence occurring in a cycle of every 12,000 years. In previous cycles, thanks to its cool temperature, the ocean used to absorb excess heat from within the Earth, release it to the surface, and subsequently into the atmosphere and outer space. But now, instead of effectively dissipating heat from the Earth's depths, the ocean retains the heat within itself. Imagine, the ocean has become like a thick blanket, holding heat underneath and not letting it escape. It doesn't allow excess heat to leave, causing Earth to heat up even more, including the ocean itself. This leads to more water evaporating into the atmosphere, and microplastics transition from water to air, accumulating there. Here's the crucial point. This microplastic in the atmosphere prevents excess heat from leaving the planet. In the end, the excess energy that comes from the cosmic influence stays on Earth, leading to intensified catastrophes.
Dang.
You can imagine this process as if we placed a hamburger in a plastic bag and started heating it. The plastic bag doesn't allow the heat to dissipate, so in this case, the hamburger heats up much more, which means the patty, ketchup, and cheese overheat even more. That's exactly what's happening to our planet. Its core and magma they are heating up even more because the heat isn't dissipating.
Wow.
And this is happening for the first time in history. This is very clearly seen on the graphs. This graph is crucial. Horizontally, it represents years, and vertically, it shows heating. The red line represents heating from the bottom of the ocean, while the blue line represents heating from the top. Before 1995, the surface water was warming more than the deeper layers, and the blue line on the graph was above the red. But then, everything changed. The water began to heat up more from below, as evident in the graph where the red line swapped places with the blue one. The reason for this shift is the rise of magma to the oceanic plates, which started heating the water column, similar to how a heated floor warms the air in a room. Because of this, the ocean began rapidly accumulating heat in its depths.
Yo. Yo.
I was laying out in the sun today thinking about climate change, as one does. It made me realize that I think a lot of people have something extremely backwards about climate change. We're always talking about save the planet, we're destroying the planet. And I think this has created this perception that if we don't slow down climate change, the planet is going to be destroyed. What I think a lot of people miss is that if we don't slow down climate change, the human species is going to go extinct. The planet is going to be here. Earth is much more resilient than the human species. Everything that is showing up as a result of climate change and our overuse of resources on this planet, from global plant pandemics, natural disasters, sea levels rising, these are all indicators of catastrophes that are going to eradicate the human race so that Earth can then reset and rebuild itself. We are so cute to think that like we're gonna destroy the planet and like we're gonna go to Mars and like in the background Earth is gonna be burning on fire and we're like off to Mars to start our new civilization. Honey, that is not how this works. And I think it could be a helpful reframe for people to realize that not slowing down and reversing climate change is not going to destroy the planet Earth. Planet Earth is gonna be here. She's that girl. She's good. It is going to destroy you and all of our future generations. And the path to extinction is miserable as hell, and we are already witnessing it.
That's real.
The accepted scientific theory is that this was a gradualistic climate change.
Yes, but that doesn't hold up anymore. I mean, in the old days, you could go back a few generations ago, coming say out of World War II, the belief was still that it was tens of thousands of years. Then radiocarbon dating came along. The problem with radiocarbon dating is the time span of deglaciation got contracted immensely. In other words, instead of being 50,000 years, now it was 10,000 years.
Wow.
What was the Earth like after the dinosaurs went extinct? This brings us to the Paleocene epoch, where the Earth was about 10 degrees warmer than it is today. There were no polar ice caps at all at the poles. But the asteroid impact caused soot and debris to go into the atmosphere and block out the sun for years. There was a dip in global temperatures for years, and in those years, 75% of all life on the Earth went extinct. All the large dinosaurs went extinct, all the marine reptiles went extinct because of the ocean acidification disrupting the food chain, and within a few thousand years after that, almost all land animals above 30 kilograms slowly, gradually went extinct. Small mammals were able to survive, eating insects, as well as small birds and small reptiles. But shortly after the impact, global temperatures started to rise, actually fairly rapidly. The impact sparked wildfires across the world, causing all that stored carbon in the trees to be released as CO2 in the atmosphere. The asteroid itself vaporized on impact, and it also vaporized carbonate rock that it struck on land, and this caused further CO2 to be released into the atmosphere. The impact also sent shockwaves through the Earth's crust and caused disruption of magma chambers. Volcanic eruptions were stirred up by this impact and spewed more CO2 in the atmosphere, as well as methane hydrates. These are ice-like crystals that are stuck on the sea floor because of the cold temperatures and pressure, but the impact disrupted those and emitted tons of methane also into the atmosphere. The greenhouse effect really starts to kick in, and by 56 million years ago, we reached the Paleo-Eocene thermal maximum, which means the temperatures of the Earth on average reach 84 degrees Fahrenheit or 30 degrees Celsius. That's like 20 degrees warmer than it is today. Even Antarctica was fairly warm and temperate. There were actually forests and tropical trees in Antarctica during this time. People forget that below the Antarctic ice, there is an entire continent of land and all things to discover. So as the global temperature starts to rise, we see reptiles begin to dominate, take advantage of this. Like giant snakes emerge, like the Titanoboa, which reaches up to 42 feet long. One of the largest snakes to ever live, as well as a giant turtle called Carbenemes, which reaches up to 10 feet long and weighed almost a ton. As I was saying before, many flying birds survived the impact, but those birds started migrating into South America and evolved to be flightless. And this is where we see the emergence of terror birds. Some of these guys can reach up to 10 feet tall and 800 pounds. See, without the larger dinosaurs in their way, all these guys were starting to fill in these niches that they couldn't have before. So they started proliferating throughout South America and evolving these large, powerful legs that can run up to 30 miles per hour. Most of these guys were carnivorous, and they were terrifying. And then 50 million years ago, mammals began to really diversify around the world because they didn't have dinosaurs in their way. This is where we see guys like the first elephants, the Phosphatherium. This guy was about the size of a dog, about 20 kilograms, but the ancestors of modern day elephants. We also see the first whales. Now, these first whales were not aquatic, they were actually land animals first. One of them called Pakicetus about 50 million years ago. These guys slowly moved into aquatic areas, so they became whales eventually. But that's why whales are mammals, because they evolved from land mammals. We also see during this time some larger mammals evolve on land, like the Barolambda, which was about 8 feet long. And then about 46 million years ago, the Earth begins to cool a little bit, and we see some birds migrate south into the Antarctic, where we have them start diving for food, and they become the first penguins. Should I say giant penguins, like the Anthropornis, which was about 6 feet tall. But as time went on and the Earth continued to cool down, a lot of the large reptiles began to die out. And we also see a bit of continental drift, like Antarctica begins to diverge away and separate from Australia and South America, and it becomes its own continent where it kind of just sits in the extreme polar south, and it gets stuck in these polar winds. And the polar winds trap all the cold inside of it, so it starts to build snow and ice over millions of years. And in the other parts of the world, the coastal areas, we see whales become fully aquatic now. Those smaller mammals are now more like primates and tree-dwelling monkey-like animals, our ancestors. And grasses begin to expand really around the world. Remember, grasses at this time were fairly new. So we have ruminant animals begin to take advantage of this niche. And as the Earth cooled down even more, this marks the end of the Eocene epoch.
That was a great breakdown.
So before they had all these ice cores, when they were saying that this climate change took thousands of years, was that just guessing?
Pretty much. That was based upon actual empirical observations of ice glaciers receding as a result of the modern warming. Because you have to understand, up until about the middle of the 19th century, we were in the middle of what has commonly been referred to as the Little Ice Age. And this is another thing that's important to put into context. The Little Ice Age was in two phases. The earliest phase came on in about the mid-1300s. Then it warmed for about a century in the 1600s, and then the second phase came on. During that time, the glaciers worldwide began to grow. And most of the evidence today suggests that during the Little Ice Age, glaciers were bigger than they had been in 10,000 years. So around the middle of the 19th century, around 1850, give or take a decade or two, the climate began to warm out of the Little Ice Age and glaciers began to recede, right? Now, if we look at glacier recession that's going on right now, and it's been going on for the last 10 or 20 years, what we see is it's basically a continuation of the recession that's been going on for 160 or 170 years, right? So it's important to establish what's our baseline. When we're comparing modern recession of glaciers, bear in mind that our baseline is we're starting from the glaciers being bigger than they had been in 10,000 years.
Nobody's talking about the fact that by 2026, scientists have to determine if they have to shave off 1 second up to 60 seconds of universal time. Within the past 24 hours, scientists have determined that the polar ice is melting so quickly that it's literally changing the Earth's rotation and it's messing with time itself.
What?
Now, when I speak of time, I'm talking about the Universal Coordinated Time System. That means wherever you are in the world, everyone has to abide by the Universal Time Coordinated System. To put it in the simplest terms possible, the Earth's core is slowing down, which is calling the exterior of the Earth, which we live on, to actually maintain and speed up at the same time. They're basically saying that scientists have done so much to the Earth with climate change and digging and looking for fossil fuels that the Earth is actually speeding up and we may have to shave off a second of time. Now, you're probably thinking, how is that a bad thing? Because we have to shave off a possible 1 second or milliseconds to a minute of time by 2026, this is going to cause all electronics to have to be reconfigured. Everything that we use now, from computers to cell phones, every and anything you can think of that is electronic, is precisely configured right down to the second. So if they have to shave off even a millisecond, even 1 second or 60 seconds worth of time, that's going to throw off everything that the Universal Time Coordinated goes by. Right now, scientists really don't know why this is happening, but they're going to have a huge meeting in the year of 2026 to determine how much of time they're actually going to shave off. And when they do this, they're actually going to have until 2030 to actually implement it, because the entire world at that point, every electronic you can think of that uses the Universal Coordinated Time will have to be configured or everything will be thrown off.
I ain't know nothing about no Universal Coordinated Time.
One ChatGPT request, that's the equivalent of pouring out a bottle of water and powering a light bulb for 15 minutes.
Wow.
A lot of people think of the internet as just being in the cloud. Really, it is taking up this huge space of these gigantic computers, which are data centers.
In Northern Virginia, we have over 300 data centers. There's around 100 million square feet.
And they use a lot of energy.
Artificial intelligence requires servers to run much hotter. Water cooling will be necessary. So where will that water come from?
One ChatGPT request, for example, that's the equivalent of pouring out a bottle of water and powering a light bulb for 15 minutes. If you multiply that times billions of requests, you can start to see the cumulative impacts.
AI is driving the need for additional power to meet this demand at an unsustainable rate.
Hold on, man. AI is dangerous. Like, because AI be lying, you know what I'm saying? They be doing a lot of stuff, you know, and it might be smarter than humans and all this stuff. And it's taking up a whole bunch of power and energy in our atmosphere. What is going on right now?
The scale of the energy use is 20, 30, 40 times more per square foot than anything else that we're familiar with.
Diesel generators are the backup power for AI applications or any data center application.
More fossil fuel emitting infrastructure that historically and currently impacts low-income communities and people of color.
We're contemplating a tripling of the entire energy infrastructure that we have today. And the effect on the average taxpayer is a doubling of their utility bills.
Everything that's needed to support this industry is paid for by the ratepayers as a whole, which is you, me, it's everybody.
To subsidize all the richest corporations in the world.
There's so much money to be made that renewable energy goals, sustainability goals, they are not at all front of mind.
We need to have a plan for how we're going to do it sustainably.
We have no time to waste.
Why this stuff is not being like considered though?
Ice in the Arctic, where I am right now, and in the Antarctic is one of the most important moderators of Earth's climate. It works through something called the albedo feedback mechanism. Sunlight that hits the Earth bounces off the ice back into space, and so it's not absorbed, which helps keep the climate cool. But when that ice melts, the sunlight hits the surface of the ocean instead, or the land, and that's much darker and it absorbs the heat. And it's a feedback mechanism because as the ice melts, the light hits more of the land and more of the ocean instead of that nice white ice. And it heats more, and so it melts more ice. So the ice in the Arctic and the Antarctic, and preserving that ice, is one of the most important ways we can mitigate climate change.
Okay, let's say in the worst case scenario, the world warms up by 5 degrees this century. What would that look like? Well, once it gets past 4 degrees is where things start to get really bad. And to give you an idea, a 4-degree difference in global temperature is about the same difference as the present day and the last ice age, where 25% of all land on Earth was covered in ice. Whoa. At 4 degrees warmer, there is no longer any ice at either of our poles, and sea levels have risen so much that almost all coastal cities have been flooded. There will also be a mass migration of both humans and animals to more northern areas like Siberia and the Canadian territories. The last time that global temperatures were this high, 55 million years ago, alligators lived in the Arctic. Most land on Earth will be uninhabitable and unable to produce food, wiping out hundreds, if not thousands of species. And what if the world were to pass 5 degrees and warm up to 6? The last time that this happened was 251 million years ago, when 95% of all life on Earth was wiped out. The oceans rose by 20 meters, releasing tons of methane into the atmosphere, meaning even a lightning strike could set off an explosion even more powerful than a nuclear bomb.
What?
Global warming might be making US winter storms colder. Arctic air, especially the strong, swirly winter vortexes, usually stay confined at the North Pole thanks to a boundary of wind called the polar jet stream. That boundary is at its strongest when there's a big temperature difference between the Arctic and the mid-latitude regions, like parts of the US and Europe. When the difference in temperature is less extreme and less reliably distinct, the jet stream weakens and wobbles and allows Arctic air to drift further south. The Arctic is warming 4 times faster than the rest of the planet.
Whoa.
So the temperature difference between here and here is becoming less extreme. And that might suggest weakening polar jet stream over time. But Arctic winds are complex systems and affected by things like the regional sea surface temperature and difference in pressure in the atmosphere, and much, much more. So there's still some scientific debate over how the polar vortex and jet stream will specifically change in the future, and over how much of an effect our changing climate will have on it. But we do know that global warming is creating more extreme weather, and we're already beginning to feel its effects.
Man, this sounds catastrophic, though.
As a climate scientist, I'm often asked what's the best way that I can help fight climate change. And I just did a search, and honestly, search engines don't seem to be that good at answering this question. So for example, I Googled best way to reduce carbon up there, and this is what came up. This is a carbon reduction plan. It's basically a carbon offset. Now, I don't want to dismiss carbon offsets in general, or this project in particular, but I think most scientists understand that carbon offsets will become really important only when we've done the really big work of reducing our carbon emissions by, a large factor. Then if you scroll down the page to the non-adverts, you get to this. It says recycle as number 1. Now, again, really important. I don't want to diminish recycling. It's important, especially for resources like electric car batteries, that kind of thing. But recycling doesn't really address the fundamental problem for climate change, which is that we use fossil fuel intensive sources of energy. And this is particularly important from a personal perspective. In your household, recycling is only going to take a tiny amount of your carbon footprint down. From a global perspective, the IPCC have done a bunch of studies and looked at this. And this is a great graph from the synthesis report, which looks at how much we might reduce carbon emissions as a society, and also the costs. So blue bars here are a negative cost. That means we should adopt them immediately because we get money back. And basically it gets more expensive with orange and red. And the size of the bar is the potential reduction in emissions. So the bigger the bar, the better it is at fighting climate change. And the bluer the bar, the cheaper it is, or even it's cost negative. But the big hitters really are shifting to renewable energy, solar and wind. And then you're looking at reducing conversion of natural ecosystems. So basically keep the natural ecosystems that you have. Then there's a relatively big but maybe slightly costly bar here for carbon sequestration in agriculture. So this regenerative farming idea. And then underneath that, you've got this ecosystem restoration. So basically putting ecosystems back. This one's also important, but really unknown, this shift to sustainable, healthy diets. So, for example, agriculture puts a lot of methane, particularly beef. So if you reduce beef consumption, that means you can fight climate change. But it's unclear how much you can change global carbon emissions by. Then down here, you've got sort of buildings and public spaces. You've got fuel-efficient vehicles look like they're going to pay us back. But making buildings efficient is going to be costly. Electric vehicles are unknown at the moment. This bit I'm particularly in, this is public transport and bicycling. I do that myself. And then further down, you've got this kind of fuel switching, energy efficiency, reducing methane from industry. This is the industrial bit. Interestingly, carbon capture with CCS is right down here. So this is really big picture stuff, and this is well worked out. but it's not really answering the question about you at home, how you can change your carbon footprint or how you can help fight climate change. So maybe we'll do that in another video.
If it costs $50 trillion, as some of your colleagues have testified, to become carbon neutral by 2050, how much is that going to lower world temperatures?
So every country around the world needs to get its act together. Our emissions are about 13% of global emissions.
Yeah, but if you could answer my question, if we spend $50 trillion to become carbon neutral in the United States of America by 2050, you're the Deputy Secretary of Energy. Give me your estimate of how much that is going to reduce world temperatures.
So first of all, it's a net cost. It's what benefits we're having from getting our act together and reducing all of those climate benefits. We're seeing.
Let me ask again. Maybe I'm not being clear. If we spent $50 trillion to become carbon neutral by 2050 in the United States of America, how much is that going to reduce world temperatures?
This is a global problem, so we need to reduce our emissions and we need to do everything we can.
How much, if we do our part, is it going to reduce world temperatures?
We're 13% of global emissions.
You don't know, do you?
So we're 13% of global.
If you know, why won't you tell me?
If we went to zero, that would be 13%.
You don't know, do you? You just want us to spend $50 trillion, and you don't have the slightest idea whether it's going to reduce world temperatures. You're the Deputy Secretary of the Department of Energy, and you're advocating we spend trillions of dollars to seek carbon neutrality, and you can't, and this isn't your money or my money, it's taxpayer money, and you can't tell me how much it's going to lower world temperatures?
Yes, get on his ass, pause.
Satellite images show us all kinds of human impacts on the planet, but there's one that might sound counterintuitive. We're also making the planet greener. According to a number of recent scientific studies, the amount of green vegetation on Earth has substantially increased in the last few decades. We know this thanks to a metric called leaf area index. And there are two main explanations for why that amount is increasing. One is that we're growing crops in more places and figuring out how to grow more crops in each place. This vegetation absorbs carbon from the atmosphere, although probably not enough to put a dent in climate change. The problem is industrial agriculture requires huge amounts of water and chemicals like fertilizers and pesticides. The other explanation is carbon dioxide, one of the key ingredients in photosynthesis. Our increased CO2 emissions are actually fertilizing plants on a global scale. So the greening of the planet is complicated. Preservation of a rich rainforest or expansion of monoculture farms both increase the leaf area index. But it is a testament to the scale at which we're changing our planet.
That's a fact. That is a fact.
Did you know your favorite AI tools like ChatGPT are actually terrible for the planet? That's because just training big AI models takes a ton of energy, which is about as much as hundreds of long-haul flights. Every time you ask AI a question, it uses a whole lot of power, and with millions of users and millions of queries every single day, it adds up to a lot of energy. Plus, data centers use water to stay cool, and studies have shown that a 100-word email written by ChatGPT is equivalent to half a liter of water. Other research has shown that ChatGPT alone consumes nearly 275 million gallons of water each week. And then there's the hardware. Chips require rare earth minerals, and when they're outdated, they get discarded. There is a way to power AI with clean energy and build it responsibly, but until then, it's just another industry having a negative impact on the environment.
Another huge industry, humongous.
How pressing is the climate change issue? Well, it's somewhat pressing. It's one of the many problems we need to fix in the 21st century. But first, you need to recognize it's not the end of the world. You also need to recognize that anything we do will really only have an impact in 50 to 100 years. This is not a question to be decided over the next 4 years. This really is something that's decided over generations. So we can fix climate change in three different ways. We can mitigate, that is cut carbon emissions, we can adapt, and we can innovate.
Yes.
Look, we're always going to adapt. We need to have lots more innovation because that's what's really going to fix it. But almost all the focus on the first, namely mitigation, because it makes you feel like you're doing something right now. But climate change is not about doing something right now. It's about making sure that everybody does something over the long run, over the century, that we get the Africans and the Indians and the Chinese to do this. And that all comes down to innovation.
You've probably heard that weather is getting more extreme, and that this is in part because accumulating greenhouse gases have caused the air at Earth's surface to warm by an average of 0.8 degrees Celsius over the last century. But how could a barely perceptible rise in air temperature lead to such crazy changes in weather? Well, that air temperature rise actually only amounts to 1% of the extra energy absorbed by Earth's atmosphere over the last century. A few percent has been absorbed by land, and almost all the rest has been soaked up by the oceans. That increase in ocean heat content is the energy equivalent of an atomic bomb exploding every second for the last 100 years. And that matters because heat stored in the oceans has a big impact on the weather.
A lot of people don't understand the link between AI and global warming. So remember when computers used to look like this and they had this box? And that box used to get really, really hot. So where did that box go? Well, now it's in things called data centers. So basically that's why we're able to be on our phones without having like a massive thing behind it, because all of the computing goes on in these servers here. So I was an information systems and analytics major in college, and we learned that you actually have to like really attend to these very well, and you have to keep them very cool. And they do that through a variety of different ways by like pumping water through them because it gets so hot in there. So one question to ChatGPT is equal to 10 times the amount of energy that it takes to do one Google query. And this fact kind of made me realize like I need to be more mindful as to what I am asking AI, right? Because I don't need to be asking it my grocery list. Praying for all the people in California, and it's just good to know this stuff because I feel like it's so hard to learn this type of information because it feels so foreign. Like could like talking to an AI cause the energy to be created, right? It doesn't fully feel logical. So I just wanted to explain that if people didn't get it.
I definitely learned something today, for sure.
Let's be clear.
Yeah.
Global warming, climate change is definitely real. It's happening.
Well,
the question
but
is
it's
why
always
has it happened?
happened.
Yes, it has always happened.
So what is the climate change? Yes, the climate changes. It was different weather yesterday than it was today. The climate is forever changing. Like that's the problem, is that people are making it seem like that's something weird.
No,
it's not
that's
unique.
not. You're misrepresenting the issue. The issue is people think that human beings are exacerbating climate change to the point where there's a tipping point. We cross over that tipping point. We're going to deal with huge problems that could be corrected if we act now and put a lot of funding into climate control.
Okay.
And this is what Howard Bloom was on talking about a few days ago. He was talking about that the real future involves the technology of climate control, and that what we have to be really careful of is letting it get too far where you can't ever stop it and pull it back. This is what scientists are warning about. This is why they want emission standards. This is why they want to figure out how to get people to be aware of the fact that this is a real issue.
Okay.
Now,
and when we speak of a climate consensus, what we're saying is that the overwhelming majority of the scientific community has produced research evidence citing that humans are responsible for climate changing in this world, leading to the warming of temperatures in the atmosphere. Period. If you want to deny that, you are denying it because it conflicts with your cultural or political principles. Okay, it's a free country. Go ahead and do so. But if you now rise to power over legislation, that's dangerous. It's irresponsible and dangerous. So the challenges are modeling climate. Oh my gosh. It's like there's the heating of the oceans from the sun, and then the oceans keep some of the heat, and they trap it and put it low. So then when the atmosphere cools, the ocean releases some of that heat back, and then the trees and the ice caps reflect sunlight back. But if they shrink, then there's more. So there's a lot of variables. There's 100 stuff. So that's why there's variance in the predictions that come from it. But the predictions all point in the same general direction. You will never have 100% of all scientists agreeing. That's not how progress in science works. What you're looking for is the overwhelming. If only half the scientific papers showed this and the other half didn't, you got no result.
I guess the question that I have about climate change, and at least its public-facing sort of presentation, is the level of uncertainty when it comes to its effects. So you can acknowledge that climate change is happening. There are people who talk about catastrophic climate change, millions of migrants suddenly running around the world, Miami underwater. We're all dead within a century and a half. So a certain catastrophic level.
We will not all be dead in a century and a half.
No, and
we'll just flood all our coastlines.
Well, and by flooding all our coastlines, it's not going to be immediate. You mean that there will be a gradual increase in sea level,
however,
which can be mitigated in certain ways, presumably.
However, consider that most of the world's most important cities are on the water's edge, historically for transportation, for commerce, and the like. The most important cities in the world are on the water. Okay. Most of the most important cities in the world are found in that way. All right. So it's not like the water level start to rise. You might, if you're following my tweets, I said if we lose the Greenland ice sheet and the Antarctic ice sheet, then all that water goes back into the ocean levels will rise.
Why they cut the man off like that?
We've had relatively stable climate. No ice ages, no hot spells, and we've had these ice caps that have remained, primarily in Antarctica and Greenland. If you melt those ice sheets in Greenland and Antarctica, the water levels will rise and come to the level of the Statue of Liberty's elbow. So we're talking not so much, oh, it's so hot, it's gonna kill me. No, we're talking about sea level change. And where are all the greatest cities in the world? They're on the ocean's edge, on the river's edge. My point is, what's gonna happen first? Coastal cities will get flooded. You're not gonna just see water levels slowly rise. That will happen, but that's not what you're going to notice first. The storm swell that previously only brought the water to here now breaches your city walls. You'll see it in the extremes of the weather, and this will destabilize the world. And you know who knows about this is the military.
All of us, and including myself until very recently, assumed that all of our main energy sources are these so-called fossil fuels, and of course their existence is going to be limited by the amount of fossils, by the amount of decaying organic material.
Not so.
So if that's not so, then we need to rethink a lot of things.
A lot. I think this one fit into a paradigm by a famous economist that I like very much. His name is Simon. Do you know about this guy named Simon? Julian Simon, yeah, the key guy, University of Illinois and then Maryland. He was the guy who said that the ultimate resource of humanity or Earth is actually not all this material thing like uranium, gold. Because uranium, there are far more uranium in the oceans than on the land, right? You have 4.5 billion tons of uranium in the ocean. You have only 17 million tons of that. Gold, copper. What do you want on the ocean? It's all there except they're in very dilute form.
Yes.
Clearly. So the ultimate resource actually is not that, it's the human mind. It's the innovation part of it. I think I like that principle a lot. And it fits very well in terms of saying that it's all matter of cost. Even oil. I don't know if any of you know, the audience know that 50 to 60% of all the oil that you already drilled, the drill hole, you can only pull out 40 to 50% of it. 60% of that remains in it. Simply because there's not enough pressure to get it out. This is why the idea of abiogenic oil is interesting, is true, clearly true. It's all matter of cost, really. Because this thing has to form way inside the earth, the mantle, which is 50 to 100 miles, right? Human, how deep have we ever drilled? Only the skin, which is only 5 miles maximum, 5 to 6 miles, basically. That's at most that we can drill. And then all this stuff had to permeate into the reservoir. I got this information from the top people that physically have to look for oil every day. One of my friends, Joseph Limecooler from Beacon Energy, offshore energy. Those are the guys who work day in and day out to bring us the energy, actually, the oil that we need.
So why don't most people know this? Why do most people think that the gasoline in their car was, by definition,
have to be limited?
Yeah, that there's just a tiny amount and it's going away. We'll never find more.
The world is full of untruth and half-truths, right? That's the whole problem, right? That's why for so long, even the idea that we are not limited and bounded by availability of, let's say, gasoline, petroleum, or coal. Coal now they won't allow us to use, right? As you know, in COP meeting in Dubai that just ended a day ago, they just physically declared themselves that we should stop using fossil fuel. Basically, petroleum, natural gas, and even coal. I mean, these people are insane now, really insane. I think they're going to harm more people with their own delusion. Plus, they always remember, these are people who actually don't represent the majority.
While every country is worried about rising sea levels, nobody has found a solution quite as effective as that of the Netherlands. In fact, they've been reversing the effects of climate change for hundreds of years now. This all started in the 1100s, when the Dutch were getting tired of seeing their towns repeatedly get flooded. Unfortunately for them, the fact that most of their land was only a few meters above sea level and located extremely close to the North Sea meant that these floods were way more common than surrounding areas. Efforts to stop these floods started off simple, with the Dutch building river dikes here and there, but as the centuries would go by, these these projects would reach immense scales. Windmills were used to drain water, larger dams were built, entire islands were created out of the North Sea, and well, you get the picture. But just to give you an idea of how insane this is, here's a map of how much of the Netherlands lies below sea level. It's estimated that more than 65% of the country's total land would have been underwater if it wasn't for this Dutch ingenuity. But what makes this more interesting is that instead of taking over its surrounding countries to gain more land, the Dutch have historically looked towards the ocean, giving birth to the phrase, God may have created the world, but the Dutch created the Netherlands.
Interesting.
Meet the mechanical tree, a machine that can do the work of 1,000 living trees. Could this tower of leaves help pull us back from the brink of the climate crisis?
The mechanical tree can do the work of 1,000 trees. It's an enhancement, an engineering improvement to a natural system, a living tree that can pull carbon dioxide out of the air. Inside each of those discs are 6 of these leaves oriented around in a circle, kind of like the slices of a pizza.
The tree's circular leaves are filled with materials that bind to carbon dioxide and pull it from the air.
So zero emissions are not enough. We will need negative emissions, which means the removal of carbon from the environment and their storage in some kind of reservoir. If we have enough negative emissions, we can counterbalance the emissions that we're still producing and reduce the concentration of carbon dioxide in the atmosphere.
There's a lot still to learn about removing carbon dioxide from the atmosphere. How do you feel about a technology that turns nature's abilities up to 1,000?
I like it. All right, guys, that was another TikTok compilation. That was very interesting. Very interesting. First, if you made it this far, you're a real one for real. Make sure you put that in the comments, man. That was very interesting, to say the least, especially regarding the innovation. The ChatGPT and the AI thing is crazy. AI is way out of bounds, man. They are way out of bounds, and people is going full steam ahead with AI. I didn't even know or even consider the energy that's, behind this technology. That's just my ignorance. I learned something new in this video, man. But we gotta do better. We gotta do better. Worldwide, we gotta do better, man. But till next time, self-love and positivity. Fire Squad, I got you, and you know it.